According to data collected, the gauge pressure is much lower than the calculated pressure reading. The relationship between the heights of water in the water tank with the two pressure readings can be concluded to be directly proportional. From graphs 1 and 2, we can notice that the gauge pressure measured and pressure calculated is linearly increased with the height of the water. Thus, it verifies the relationship of the pressure measured and pressure calculated with the height of the water as mentioned in the discussion before. Based on the graph, the water flow rate is directly proportional to velocity measured and the same goes to velocity calculated. When water flow rate increases, the measured velocity and the calculated velocity is also increased. These can be verified through the graph plotted. The calculated velocity is different than the measured velocity because of the low accuracy in the pitot tube itself. Human error may also happen that makes the person taking the wrong H1 and H2 reading. During this experiment 7C, the Archimedes principle is used to determine the buoyancy force acted on the aluminium bar when submerged in the water. When the weight of the aluminium bar increases, the volume of water displaced is also increasing. Thus, the buoyancy force acting on the aluminium bar is also increasing. Therefore, it can be concluded that the larger the weight of the aluminium bar, the larger the buoyancy force acting on the aluminium bar as it displaces more water. From the data recorded, it proves the validity of Boyle's law where pressure is inversely proportional to volume provided that the temperature remains unchanged in the closed system. It can be observed that when pressure decreased to 0.26 bar from 0.36 bar, the volume of the gas increased from 9.8 L to 10.0 L. However, the PV value in tank 200 mm is higher than the tank 100 mm. This is due to the size of the water tank and the amount of gas inside the water tank. Thank you.